Okay, as you recall, we've previously talked about factoring a difference of squares, and we determined that the model we could use was a squared minus b squared factors as a plus b and a minus b. For example, we have x squared minus 9. We can think of x squared minus 9 as an x squared minus a 3 squared, and we can factor that where the x is like the a and the b is a 3, x plus 3 and x minus 3, just fitting it to the model. 16x squared minus 49 can be thought of as 4x squared minus 7 squared, so it's a difference of squares. The a is the 4x and the b here is the 7, so we can factor that as a plus b, or 4x plus 7, and a minus b, 4x minus 7. So this was the model that we've been working with previously. What happens though when we have a sum of squares, a squared plus b squared? Well, it'd be nice if we could factor it in a similar way, and as it turns out we can. There's a little trick involved. We need to recall that the square root of negative 1 is equal to I, and also that when we square I, we get a negative 1. Using this idea, we can rewrite this a squared plus b squared as a difference of squares in the following way. We can say a squared minus a bi squared, which is actually equivalent to an a squared plus a b squared. Let's go ahead and multiply it out and show that that is the case. We have a squared, or I guess I should, and we square a bi, and we get a minus b squared I squared. Now I squared is equivalent to negative 1, so we have a minus b squared times a negative 1, which indeed does give us an a squared plus a b squared. A minus b squared times a minus 1 is a plus b squared. So we can see that a squared plus b squared is equivalent to an a squared minus a bi squared. Okay, what that allows us to do is then we can say that since a squared plus b squared is equal to the difference of squares, a squared minus a bi squared, we can factor this sum of squares similarly to what we did earlier with the difference of squares, and factor a squared plus b squared as a plus a bi times an a minus a bi. And so this becomes our model for factoring a sum of two squares. So our model for factoring a sum of two squares, a squared plus b squared, is a plus bi and a minus bi. Here we have an example. A squared plus 9. Again, we can think of this as a squared plus 3 squared. So the a is the x and the b is the 3, and substituted into our model here, we get that x squared plus 9 factors as a, which is x, plus bi, should be 3i, times a, which is x, minus bi, should be 3i. Another example, 16x squared plus 49. Okay, we can think of 16x squared as a 4x squared, and 49 is 7 squared. So using our model, sum of two squares, we get that this factors as 4x plus 7i and 4x minus 7i. And that's all there is to factoring a sum of squares over the complex numbers.